All right, so things to consider for this project presentation. Starts off very similar to the last one. Title, subtitle, your name, overview, why are you doing this project, your motivation, you're gonna set up your business case. And yeah, explain why you're doing this analysis and possibly a preview of your results. Sometimes this is effective to show your results and then bring your story back to how you get there. So with this next slide, what data did you use? What are your sources? A very brief snapshot, things like the time frame of your data, like when did these car crashes happen? With this customer's churn data set, what time frame are you looking at? A really good one to include here, I think, would literally be your class balance. So because you're setting up your problem in the slide before, here you could say, all right, I'm predicting the status of water wells, and the 3 classes are it's fine, it needs repairs, or it's completely broken. And I think is a really good idea to also talk about the distribution of that. So literally, like, what is your class imbalance like? Is it like a 90%, 10%? Is it like split evenly amongst 3 classes? I think this is a good place to mention that. So let me actually type that out here. Distribution of your target class. Is it imbalanced? Balanced? Maybe some percentages. All right. After this, and this actually would lead in pretty nicely to your EDA section. Here, your EDA, try not to just dump all of your EDA graphs. I think that's something that, at least in my other class, that's something that I saw a lot of just like, here are all my histograms. So any visualizations that are relevant to your analysis and modeling. So you really have to put yourself in the shoes of, all right, I'm presenting this model. What would my audience be curious about, right? Like if I'm doing a Terry stops data, like people getting stopped and frisked, what would they be interested in? Literally, like, what are the features that lead most to people getting stopped? So this, and I also say here, guided by your model results. So one, as I mentioned last time, you can annotate your graphs as needed. Don't do a dump. And then also guided by your model results. So what that means is perhaps, and sometimes EDA is sometimes a back and forth process. Sometimes you do EDA first. Other times you can also do your EDA after your modeling. So for example, if you really like have a lot of data to deal with and you don't know like where to even start, maybe just run a model. Something like a random forest or a decision tree can give you your feature importances. And then maybe those will be the features you look into for your EDA. So let's say for your Terry stops data, maybe gender is a very, very significant variable. Like I think there are some like implicit biases going on, but like more men get stopped and frisked than women, right? So perhaps because you know that that's going to be one of your results, bring that into your EDA. Maybe just plot a couple histograms of like the distribution of like, or the proportion of like male to female people who get stopped and frisked. Do that. But again, guided by your model, that's one way to sort of simplify or streamline your EDA that you're about to present to your audience, because something that the things that you show here will end up connecting nicely to when you show your model. Questions about this part? All right, well, maybe less relevant for this project, but here might be a good place to mention any feature engineering that you did. All right, following the EDA, you can get into your models. Whereas previously with the linear regression project, the modeling process was more of like, I have my baseline, what steps am I taking to improve to get your final model, right? And it's kind of like a linear process because each thing sort of builds upon each other. In this case, you're running a lot of different models. At least that's the approach that I think most of you are gonna take. You're gonna literally dump your data into all your models. So I think it might be a good idea to present your final model or an intermediate one if you think it adds to your presentation. And some things to talk about, how does it compare to your baseline? You don't need to like show all the metrics of your baseline model. Maybe just say like, maybe show like your accuracy, precision, or recall F1 for your baseline and compare that to your final model. Or a couple other intermediate models, only if you think it does add to your presentation. something that's good here, this might not be something on your slide, but this could be something that you say. A quick 1 to 2 points about how the model works, right? Let's say you say, my final model is XGBoost, and you're just like, all right, there. I'm sure people will be curious, like, all right, how does this model work? What is it doing that makes it different from other models? 1 to 2 sentences that summarize how the model works non-technically. So you don't have to go too much in advance, but for example, with XGBoost, you can just say something about XGBoost is a model that, you know, trains a model sequentially. I guess sequentially might also be too technical, but you can sort of say it runs a model, takes a look at the residuals of the model or the errors that the model has made and retrains your model based on that. Something along those lines, just to give your audience some context on how your model works. Also a good practice to make sure that you understand how your own model works. Also talk about why you chose this model. If you want to do like a big comparison, like if you remember with my example project that I showed you all, I had that table of all of my results. You might want to do that here, but you don't have to talk in detail about all of your results. Something you can do is, actually, let me just pull it up. It is over here. Maybe you have like a screenshot of something similar to this. And in this case, I chose my naive Bayes model, maybe like annotate and highlight my test accuracy or your test F1, or here I even took the time it took to run the model, and the naive Bayes was the fastest. So depending on what metric led you to choose that as your final model, highlight that. Also worth talking about here, your false negatives and false positives, because if you're talking about which metric you chose your model, whether it's like recall or accuracy, that's where you can talk about, you know, the context of your metric. So finally, evaluate your model and interpret your metrics. This could be a couple slides. If you did something like evaluate, what I mean by evaluate your model, if you do something like any tree model that you can get your feature importances from, you want to do that because you want to give your model some context. So that's where you'll do that. What do the misclassified points mean? A very common visual for this slide is the confusion matrix, because it just really shows what was classified correctly and incorrectly. You might want to say a couple sentences about how to interpret the confusion matrix. But yeah, in that context, what does it mean to misclassify some of your data? And also, what are the contextual implications of your model? Like if you're saying that your model has an accuracy score of 82% and a recall score of like 50, what does that mean? It's good at predicting overall, but it's not very good at looking at false negatives. Yeah, false negatives. So that's something to think about as well. Questions so far? I feel like I just did like a big spewing of things. Questions?
I have a question.
Mm-hmm.
So you talked about using a decision tree to find feature importance.
Yes.
I forget decision tree specifically. So that's one way. That's one of the outputs you can get from it, I guess.
Absolutely. Yeah, I am currently working on like similar to what I did with all of the statistical distributions. I'm planning on doing like a big summary sheet with all the models, and I'll like mention like what are some of the pieces of information you can get from each one. And yes, from any tree model, so all the bagging and boosting models will work as well. They have this one attribute known as feature importances that will give you like the ratio of how important the feature is. And if you do like a quick Google on Stack Overflow, there are a lot of pieces of code that can translate that into like a graph, where you can literally have like a bar chart and see like which one is more important.
And if you do, suppose like you run your models, you find like you get feature importances, but then you end up staying with say k nearest neighbor. You can still use that feature importance for it'll still work on your EDA, even if you go with a different model.
That's a really, really good point. Yes, because some models, like k nearest neighbors, is a little bit harder to extract like that kind of feature weights from, because k nearest neighbors is literally just like distance. There is a way to like unpack that distance, but I would say it's not something that makes sense for this project, just because of like how much extra work you'd have to put in. You have to literally like write a function to do it. Yeah, that's a really, really great point. I didn't even think about that. That yes, if your final model ends up being something that is harder to extract information from, you can use one of your other decent models to get that information, for sure. Yeah, that's a really good point. Thanks, Henry. Any other questions? All right, well, the rest of the presentation will be very, very similar to the last one. In terms of summary and conclusions, one thing I really wanted to highlight with this part, again, you're summarizing all your insights and add overall recommendations. Your recommendations should be model-driven or data-driven. So literally, if you want to make recommendations on like car crashes, right? Like you want to prevent severe car crashes, what are some features that contributed to the severity of car crashes? Literally say, something like, well, don't drive in the rain because driving in the rain has led to whatever percentage more car crashes. So you would have to do a little bit of like data work to like find out like what is the proportion of like rainy day car crashes versus not. And then you can have like more data driven recommendations. It's good to quantify these things. If it's something that you pull out from feature importances, you can talk about that. So your feature importances will give you like a ratio of how much each feature contributes to the classification. So in customer churn, maybe something like them having an international cell phone plan leads to more churn. You can say that international cell phone plan contributes to like 78% of the classification from this model. So you can, it's good to quantify whenever applicable and whenever possible, things like that. And then if applicable, next steps. I think this is pretty self-explanatory. Any of the things that you wish you could have done. And then finally, like your thank you slide. This is exactly the same as it was last time. But cool, hopefully that shed some more light on, especially I think like the EDA section and the modeling section, what to have in your presentation. Again, happy to look over presentations before you do it. I know it is tough because most people leave the presentations at like the very last thing to do. So I'm happy to look over presentations and let you know like what you're missing or if something is like extraneous. So yeah, any other questions? With this rest of the time, I didn't have anything else planned. So happy to talk about anything else project related.
So I think I can't remember what study session it was, but we talked about how to pick your baseline model. Can we go over that again just to kind of clarify?
Yeah, absolutely. So baseline model, there's a couple ways to go about it for this project, I believe. So here, yeah, I say multiple ways to determine your baseline. Your baseline model could really be the first model that you run. It really doesn't matter in this context of that you're going to throw your data into every model anyways. So that can be your baseline. Some people like to define their baseline as sort of like after you decide on what your final model is, your baseline is the first time you ran that model. So it's kind of up to you to determine where you want to set that baseline point. Because I like to see the nice numbers on my resume, like to find the worst possible baseline. So that's why I have here the dummy classifier, which is one that does like, it randomly picks, you can choose a strategy for it to be a bad classifier. So here, it literally says here, it's a baseline to compare with other real classifier, which implies that this is not a real classifier and don't use it for real problems. And some of the strategies, I like to use most frequent. So it always predicts the most frequent label in the training set. So if you have imbalanced data, you're gonna have a 90% accuracy, but your recall is gonna be 0. So that would be your baseline. Or you can do, I think, yeah, here, stratified, it's more of like a probability based, where it'll try and predict based on the distribution of your train set. And yeah, constant is the same here. Uniform, I think this is also just like, yeah, it's sort of like randomly choosing either class. So I like to use this as a baseline just to show a bigger improvement, but it's up to you. It's really up to you.
Okay, cool.
Mm-hmm. Yeah, or you can have 2 baselines, honestly. You can have a couple of baselines. You can really just define this as like the baseline, and you can have like a more like model specific baseline. Let's say you choose XGBoost. Your first XGBoost has like a for example, 80% accuracy, or let's go with like, yeah, 80% accuracy, and then you're going to work to improve that. Because usually within each model, you get a very marginal increase. So, yeah.
I have a question to follow up on that.
Yeah.
So if you like wrote a function that just does all the models, can you just say like, hey, or you pick 2 models that did, you know, the best out of those, let's say like 5. And then you can say those are your baseline models, and your final model would just be improving on those 2 original baselines that you picked.
Yeah, absolutely. You can do that. If you want, you know, if you want your notebook to follow a narrative, there is no rule that says you can't rearrange your models. You can arrange your models to have like the worst ones first and then they get better. But yeah, you can do that as well.
Question. Yeah, question. It's funny. So I saw in the notes here on the other page.
Yeah.
You said, well, we could focus on a particular metric, right? So, for example, recall. So, if I decide to focus on recall, would you still want me to, like for the presentation, to actually show the F1, to show the accuracy scores and all of that, or can I just focus the presentation on the recall score?
Yeah, I will say it's up to you. I think for things like accuracy, it's pretty self-explanatory. With recall, I would say if you want to just show recall in your presentation, I think that would be fine. But also contextualize recall. Just say you're focusing on recall as a metric because recall looks for reducing the number of false negatives. So if you say something like that, I think just showing recall will be fine.
So as long as we contextualize it, then I don't need to show the other scores.
Absolutely. Yeah, that's right.
Okay. And then this is just if you can answer this, I'm not sure. But you mentioned just like, you know, for your resume, you say, oh, well, I like to have like the lowest score and then have like, can you just give, if you had to just say like a sentence to say like what you would write on a resume, like in that case, like what would you say? Would you say, could you just give an example?
Let me pull up my own resume. I think I have it here.
Yes, absolutely.
So I'm not going to show it to you all.
Oh, okay.
But I'm going to read the sentence. I'll read the sentence that has that.
I had the screenshot button ready.
When y'all get to your career phase, I'm more than happy to like share what my resume looks like. So this is actually for my Mod 4 project, where my sentence actually says, improved accuracy by over 200% from a baseline of 20% by applying transfer learning methods and pre-trained networks. So that was a neural network project, but just having that improved accuracy over 200% from a baseline of 20%. Yeah, I feel like that sounds nicer than saying that like achieved, because I think that ended up having an overall accuracy of like 60%, I think. But you know, the way that you phrase it, and just having a baseline to compare to.
Sure. Good. No, that's pretty cool. Thank you.
Yeah, you're welcome. That's something that career services really helped me with. So yeah, shout out goes to them. But yeah, that's why it's important to have a baseline, because people like to see, you know, the journey of your project. And I think that's what a baseline helps achieve. Yeah, anything else? Let's see.
I have a few questions. So as I said, we were talking about today on our 101, and my model's imbalanced. So what I've been doing is, so first I scale the data, and then I run Smote to balance it, and then I run the test data, correct? And I see how the scores are. And my scores, even after I balance it, my scores still aren't all that great. I guess they're a little bit better than before I balanced it, but still that's like a kind of a baseline for me to start to refine if I decide to go with that model.
Yeah, so actually this is a good segue to talk about Smote. I think when I think with you all, I didn't go in depth into Smote at all with either of my cohorts. So I think that this is a good segue into like, why would Smote help and why would Smote sometimes not help? So overall, and let me get some annotations going over here. So what is Smote doing? Smote is pretty much generating synthetic data to rebalance your classes. And sometimes it works, sometimes it doesn't. So as an example, imagine that these stars are all data points from one class, and let's just have it like trickle over here. And then I have a minority class of like, let's say I have, see what other stamps are here. All right, let's say I have these minority class of question marks. So my minority class of question marks, let's say it's like this here. And with my model, because it's so imbalanced, it, for example, is predicting way more stars than question marks, which makes sense because it doesn't have too much from question marks to learn about. The way Smote works is it creates more question mark points within this region. So hold on, I'm drawing this. It looks at where in the feature space the question marks live and creates synthetic points within that area. So what that's doing is, let's just do these ticks as the synthetic data. So what's gonna do is it's gonna do this. So sometimes this works, sometimes it doesn't. You can imagine that if your question marks were already pretty separate from your stars, you will end up getting a much better classification model. You'll end up with a much more, you'll get more improvement. But if off the bat, your question marks are very intertwined with all your stars, creating more question marks might not help, right? It might give it more intricacies to look for, but if it's so overlapping and there aren't many features that differentiate the two classes, it's not going to help very much. And that's really just like a limitation of the data. Like no matter how you oversample, undersample, very, very similar effect. If they just overlap a lot, it's going to be much harder to classify. So that's how Smote works. Hopefully that was helpful. One other thing I wanted to talk about with Smote, and I'll just leave this here, how to Smote. It's not fit transform, it's actually called fit resample. So again, to prevent data leakage, because you know where your synthetic data points are created is constrained by where the minority class is, you only want to do that on your train. Also, you don't Smote your test data, right? Because why would you want to test synthetic data? That doesn't make any sense. You're just using the synthetic data to train your model, but when you're testing, you don't need to test. So what that means is, it even goes, and this part is kind of confusing for some people. So if you get your y hat train, right? Y hat train is your predictions from your, Y hat train is the predictions from your train set. You would do your model.predict on your X train. Compared to when you do your, let's call X train Smoted. We do, I forget what it is. I forget which order it is. So I think it'll do like Smote.fit resample X train, something like that. Okay. Is it a fit resample?
Yeah, there's no resample. I think it's just sample. At least that's the way I did it.
Oh, okay. All right. Fit sample. So here what we're doing, we're creating our Smoted data. And then we have our, we have our Smoted data there. So when you have your model, when you do your model.fit, you're going to do your X train Smoted. Oh, and you also have your Y train Smoted. And this is going to be on your Y train. So you're fitting your model on the Smoted data, but when you make your predictions, you don't make your prediction on the Smoted data because you have a bunch of like synthetic data points that it doesn't make sense to make predictions on. So when you make your predictions, you're just going to predict on your X train. If that didn't make sense, that's okay. That's not something I'm going to nitpick on, but this would be the right way to deal with Smoted data. And if anyone needs clarification, please let me know. We can talk about it during like a one-on-one in the context of your project. I think sometimes that's easier as well. But yeah, that's my spiel on Smote. Any other questions? I'm not sure, Henry, did you ask other questions? I forget.
Yeah, it's kind of like that's kind of partly there. I keep getting an error too when I'm trying to run the accuracy score on the balance data. It seems to give me an error saying classification
Mismatch?
metrics can't handle a mix of binary and continuous multi-output large targets, not large. And I got it. I don't know. So do I run? Because you were telling me to run to do confusion matrices to get scores on the training data as well, so I can compare the training and the testing and see if there's overfitting.
That's right.
So yeah, I get it. The confusion matrices are fine, but when I just try to run the actual like score, you know, like accuracy, whatever it is, I'm getting these errors. I don't know if it's just something that you do differently or what, but
yeah, do you mind sharing your screen for us to take a look?
oh sure.
Yeah, let me just clear all of this. All right, let's see.
So how do I share my screen?
And I know yours was SMODed data as well, right?
Yes.
Okay. Yeah, some of you might run into the same issues.
Okay.
Okay, let's see. So you have your X train scaled balance, Y train balance.
I'll just go through what I did. So
okay.
So first I did train to split. I scaled the data. I balanced this data
Nice.
with fit sample. Ran the model is the k-nearest neighbor one. I fitted on the balance data.
Nice.
For the X train scaled balance, it's just I didn't have to scale the Y because it was, you know, binary.
Nice.
And then test predictions, just did it on the test scale data. I got this confusion matrix, which isn't all that great looking, I guess. And then let's see. Yeah, then I have this function for scoring.
Nice.
So this is my scoring for
the test set, right?
the test set, right? And then
nice.
Here I'm checking for overfitting. So here I did it on the X train scaled balance data and the Y train balance data to see
nice.
to see how the model would have run with just the data that I had. So it's better, but it's still not that great, I guess. Well, yeah, it's pretty good, I guess.
Yeah, it's actually pretty good.
But then when I try to run the scoring on it, I get this weird error. Classification metrics.
Continuous bouncy output targets. One thing to look at is yours is Y true, and it takes in Y true and Y pred usually, right?
Go back. I did for this one I did X train scale balance and Y train balanced.
So you actually want to do your Y. You want to get your predictions from here. So wait, can I see the last time you used your scoring function? Can I see that?
Up here.
Here, right? So it takes in your predictions from X test and then your Y test. So instead of giving it X train scaled balance, you need to create like the predictions from X train.
Oh, so I gotta run the model again.
You just have to do another dot predict. So.
Oh, okay.
Yeah. Yep, and then that should.
So right here, I did the dot predict. Right here, I have to do this again.
Yes, but on your train set.
On my train set, and I use the X train scaled balanced again, the whole.
To fit the model, yes.
Okay. All right, cool. I'll give that a shot. Thanks.
You're welcome. Yeah, sometimes it gets hard to like keep track of all of the data frames. That is
all the trains.
Yeah,
which ones you have to do, right?
Yeah, there is one notebook extension. I'm not sure if Jupyter Lab has extensions, so I'm not too sure about that one. Oh, okay,
it's slightly different, but yeah.
But there's one that helps you keep track of variables. I personally have not used it. I just trial and error until I get the right variable sometimes. But there is one that basically gives you like a little screen, I think, and it shows you all of your variables. And I think you can click on it and it'll show you where your variables are. So maybe worth exploring if you find that you're like losing track of all of your data frames.
But I didn't realize I didn't realize I had to do another dot predict on it.
So you want to run your training data through your model to see how it's doing with your training data. Yeah. Cool, nice. Glad we talked that one out. Any other questions? That is okay. Oh, yes.
Oh, this is might be a silly question, but I just updated my system. Should I be wary of any crazy things that's gonna happen? Have you heard anything
Are you on a
with the
Mac
new?
or a
What's that?
PC? Are you on a Mac or PC?
Sorry, Siri activated. Okay, what's up? Sorry.
Are you on? Oh, so you're on a Mac
Yeah,
computer.
OS.
Did you just? Is it the Big Sur that you're
Mhm.
on now? The main thing I know it happened with Catalina. The main thing with the system update is that it changes your default terminal shell to Z shell, not
Mhm.
bash. So some of the commands are different. It will tell you when you open your terminal what you're using. But honestly, most of the things are the same. On this computer, I use git bash. On my other computer, I use the Z shell. A lot of them are the same, just like some of like the branching commands are different. But that's the only thing. Were you already working on Catalina before this?
I was, yeah. So I should still be on the Zish, yeah. What was it
Okay.
called? Z shell, something like that. Yeah.
Yeah. Okay, then that should be fine. I know if you went from the version before Catalina to Catalina, they actually move all of your Conda packages into a different place. And you just have to tell your computer where they are.
Okay.
So what I did was I just re-downloaded everything in the new place it wants to look for it. But I found out later that you can redirect where it looks for packages. I don't remember what it is. I have to like look through my Slack to find. A coworker sent that over to me. But yeah, if anyone runs into issues like that, I think most of the people here are not on Mac computers. I think you might be the only
lone one.
Yeah, but I am as well. But yeah, if you run into issues with like not finding packages, let me know.
Oh.
Cool. That's a good thing to just keep in mind for sure. Yeah, any other questions? Okay, well, sounds good. Our next study group is our next office hours on Monday. I didn't have anything in particular to talk about. If I come up with anything, I will. I was thinking perhaps like a summary of all the models and like what information you can get from those and like things to consider when using each model. Yeah, if no one has any objections to that, that's all I'll do. So sounds good. If there are no final questions, going once, going twice. All right, well, everybody have a good night. Again, please respond to the prompts that I put in the respective dataset channels. I think it'll be really good to get a conversation started. And as usual, any questions, just feel free to Slack me. All right,
Peace.
bye everybody.
Everybody.
See ya.
Bye, guys.